Welcome to Chemistry in the Kitchen with the Keys. Today we are going to do the molar volume of a gas lab. You will need your lab sheet as well as a pencil to record the data so that you can do the calculations later on your own. So to begin with, you are going to have a known mass of magnesium, which I have pre-weighed for you. We'll get to that in a second. It's going to react with hydrochloric acid in a water displacement kind of reaction that will take place in this beaker and in this graduated cylinder that you'll notice has a rubber stopper with a hole in it. And if I flip this over in the beaker, I'm going to get the reaction of the magnesium and the hydrochloric acid in the graduated cylinder, which, as you can see by the reaction on your paper, that you're going to produce hydrogen gas and magnesium chloride. It will collect in this graduated cylinder because we know gases rise to the top. It will push the liquid out and we can measure the volume of the gas here. So take a look at your lab sheet for a moment with me. So this is the reaction that's going to be taking place in the graduated cylinder. It is magnesium solid plus 2 moles of hydrochloric acid, which are in an aqueous solution. That's going to create a new aqueous solution of magnesium chloride and hydrogen gas, which is what we are collecting by the displacement of the water. From this, you will be able to calculate the molar volume of the hydrogen gas. Molar volume, if you recall, is the volume that would be occupied by 1 mole of a gas, in this particular case, the hydrogen gas. It is a function of temperature and pressure, and so we are going to have to also measure the pressure and the temperature of our system today. I have a thread here. It's just a sewing thread that I have cut into a length about 12 inches or so. In my hands, you can't see it very well, but I have a tiny little piece of magnesium ribbon. I'm going to tie the magnesium ribbon onto this string. The mass of the magnesium ribbon is 0.0064 grams. In the graduated cylinder, we have 3 milliliters of 3 molar hydrochloric acid. I am going to fill the graduated cylinder with water until it reaches the very top of the graduated cylinder. The reason is that I want to be able to measure exactly how much gas this reaction is going to take place by the displacement of the water in the graduated cylinder. Here is the magnesium on a string, and I will try. Oh, this is a 1-hole stopper. So I'm going to put this in there. So you can see I'm displacing water already, so it's a nice tight fit. And there is the magnesium inside my graduated cylinder. You can see bubbles forming around it already, so it's starting to react. So I'm going to flip it over into the beaker, and we'll get the camera to watch here, and you can see the bubbles maybe that are forming inside, telling us that the magnesium is reacting indeed, and we're filling up our graduated cylinder with gas. So you can see the space up here at the top that's the collection of gas. So we'll let that go and I'll show you the results after it has finished reacting completely.
The temperature of the water is equal to the temperature of the gas inside of the water, which is currently 21.1 degrees Celsius.
Okay, so we are going to be recording the data that we collected. 21.3 is the temperature of the water of our system. That would be degrees Celsius. Today we're going to use the atmospheric pressure as the pressure of our system. As you can see on my barometer here, it is 31.95 inches of mercury. So you will have to do an appropriate conversion from inches of mercury to millimeters of mercury, which is equal to torr as well. And James will proceed in that calculation to demonstrate how that is done. The number is 31.95 inches of mercury, and we will have to do a simple conversion of this to get to millimeters of mercury, which is torr. So it's 811.53. In this experiment, the water makes our gas wet, and so we have to consider what is called the vapor pressure of the gas. So it is based upon the temperature of water. So we're going to look inside this book that has all kinds of chemical data, and you can see we have a number between 20 and 22. So we'll just round up to the 22 and use 2.6453. Notice it's in kilopascals. If you recall, there's 101.3 kilopascals to every 1 atmosphere. And there are 760 torr in 1 atmosphere. So doing the calculation, you get 19.84 torr. So you will need the volume of the gas that you have produced in this demonstration. So as you can see on the graduated cylinder, we're actually upside down. So you have to measure from top to bottom. So it's about 5.8 milliliters of hydrogen produced in this reaction. We have completed a second trial, and as you can see, the mass of the ribbon was 0.0068 grams. The temperature was 21.7 degrees Celsius. The barometric pressure and the water vapor pressure remain the same. So now you can average your 2 trials together and base the rest of your calculations on that average. We've produced a flammable gas here in this tube. So I'm going to let the water out, but remember, gas rises. So I should have trapped in here still the hydrogen gas. Ready?
Bye-bye.